Good morning, everyone, and welcome. My name is Martin Hagwall, and I have the honor to introduce St. John here this morning, who is, I would say, one of the world's foremost experts in virtual reality as applied to video games and entertainment. St. John has been a game developer for over 25 years, and he's worked with a range of companies, including DreamWorks, Warner Brothers, and Pixar. And St. John was part of a virtual reality dream team at DreamWorks that decided to jointly start a startup, Spaces Incorporated, a couple of years ago, and has already reaped a number of successes in that role. He's also teaching at the University of Southern California. I had the great privilege of working with St. John in Hollywood when I lived there, and I'm very pleased that he's been able to come and speak to us here at the conference. Please welcome St. John.
Thank you, Martin, for such a warm introduction. I had the great privilege of working with Martin Hagwall when he was in Los Angeles. Thanks as well to the Sweden Game Arena and to the organizers, Per Backlund and Magnus Ling. It's really a pleasure to be here and an honor to speak to you all. Some of you are designers, some artists, and some are programmers. Today's talk has a little bit of everything for all of you. It's a little dense, and at the 11th hour I had to cull a number of slides from the talk in order to get it under the required 30 minutes of time. But luckily for you, I have the slide deck in its entirety, and it's already available online. I'll be giving you the URL at the end of the talk. So, designing games for VR. Most developers new to virtual reality approach this emerging medium with the lens of video games that have been dominant in the modern era of interactive entertainment. And intellectually, we know that this approach is fraught with peril. Yet we are unaware of many known best practices or are unable to invest time and resources to develop the language and shared understandings for VR development. So, in this talk, I will share what I have learned in my last 25 years of video game development, including lessons that I have learned from the past 4 years of VR research and development at DreamWorks Animation and at Spaces. So a little background information, just to give you a perspective of where I come from. My career in video games has been sort of a kind of a perfect on-ramp for virtual reality development. I specialize in a few areas of art, namely character art, environment, rigging, game design, and UI design. I've served across a broad range of disciplines, which has assisted my growth as a founder, executive producer, artistic director, and educator, teaching advanced games at USC. Most recently, I've spent the last 4 years at DreamLab, division of DreamWorks, and at Spaces as a researcher, designer, and an artistic director for VR products that include augmented reality, mixed reality, and VR for both mobile and consoles and for theme park rides. When talking about best practices in virtual reality, recommendations often conflict because there are several technologies that fall under the umbrella of virtual reality. So today I'll primarily be discussing computed VR, but let's frame the discussion with a few definitions. You've got to talk about exactly what aspect of VR you mean to discuss anytime you're talking about what to do and what not to do. There's filmed VR versus computed VR. There's first person versus third person, seated versus walk around, and bodied versus unbodied. And you can mix and match these in any combination and arrive at different best practices. So first, film VR. For the most part, film VR is mono stereo, which means it lacks depth due to the high cost of stereo cameras at this time. it's limited to a passive experience. And this is because film VR does not allow for any open world movement. At best, you can create branching narratives. But true interaction is nearly impossible. Film VR is almost always unbodied because setting up a tripod and masking it out in some After Effects package is generally a good practice. Really the best way to go. In some experiences, the camera is strapped to a driver's helmet, but because you can't control the avatar, it's difficult to achieve immersion. So for that reason, the vast majority of film VR experiences are third person. It's going to be on a camera mounted in the center of the room somewhere or at some strategic point that represents where you are as an unbodied avatar, which we sometimes refer to as a ghost. Computed VR is truly interactive in the sense that video games developers have come to understand it. You can freely move about the environment and interact with objects, but immersion is challenging because the environments are often non-photoreal. However, this is a huge benefit if your intent is to immerse your audience in a fictitious world. It can be first or third person perspective and works quite well for both. Bodied experiences work best in VR because they give you the kind of faculty that you need in order to interact with your environment. And also for the reason that it's much easier to rig an avatar using traditional video game techniques that allow you to interact with the world. So let's talk about presence. The quality of VR is typically described as immersion, which can loosely be defined as when a player becomes so physically and emotionally and mentally invested in the experience to a degree that they lose their connectivity to the real world. So exactly what is presence? I'd like to quote Michael Abrash in discussing presence. He said, "It's the sense of being someplace else while in virtual reality. Many people feel as though they have been teleported. Presence is an incredibly powerful sensation, and it's unique to VR. There's no way to create it in any other medium. Most people find it to be a sort of a magical experience, and we think that once people have experienced presence, they'll want it badly. You know you've nailed presence when your guests exhibit reactions and express true fear or true joy, such as flying or fear of heights." Now, objectively, there's two qualifying components to creating effective virtual reality. The illusion of presence has four key components. There is tactical immersion, which is experienced when performing tactile operations that involve skill. Players feel as if they're in the zone while perfecting actions or that result in their success. There is strategic immersion, which is more cerebral, and this is associated with mental challenges. Chess players experience strategic immersion when choosing a correct solution among a broad array of possibilities. Narrative immersion occurs when players become so invested in a story as to when you are experiencing a movie or reading a book, and the outside world just fades away. And spatial immersion occurs when the player feels that the simulated world is so perceptually convincing as to be teleported to that world. They feel as if they're there, and that the simulated world, whether photoreal or imaginary, is for all intents and purposes real. And one thing that's really remarkable about VR is that people will talk about experiences not as though I played that game, but rather I was there, I went to this place, and all these crazy, incredible things happened. So immersion is the key. And therefore, performance issues are the #1 barrier to immersion. Our goal as creators is to design experiences that are immersive, fun, and engaging. The obstacles to achieving this goal is both creative and technical, since external reference points are, since disorientation, nausea, and eye strain can prevent your audience from fully engaging in the experience. no matter how thoughtful or well-designed the experience is. As it relates to simulator sickness, comfort and visual fidelity constitute the largest risk towards derailing immersion. Sim sickness is a more acutely experienced in VR, since all of your external references to the outside world are completely blocked off. Your vision, often when you're wearing headphones, any sort of auditory simulations, completely blocked off. And they may be incongruent to any remaining sensory feedback. Studies have shown that rotational motions, especially acceleration and deceleration in VR, significantly increase in nausea and other symptoms of motion sickness. So the keys to solving sim sickness is to eliminate the source. Incongruence between the simulation and their effects upon the vestibular system. The vestibular system is the sensory system that provides the leading contribution to the sense of balance and spatial orientation for the purposes of coordinating movement and balance. While we understand that it is directly responsible for sim sickness, the actual mechanism for the nausea is not precisely understood. There's one widely accepted theory that the reactions are triggered by the brain's false conclusion that the visual disorientation is evidence that there is some kind of a neurotoxin in our body. So accordingly, oh God, I've been poisoned, please get rid of it, and you get nauseous, and then you vomit, and then problem solved. It may be completely apocryphal, but it's the best explanation that we have today. So now we're going to talk about performance issues and how to improve them. As it relates to, well, let's talk about latency first, and let's talk about what it is. The virtual image needs to be in the right place at the right time, which means that the latency has to be very, very low. As measured from the time that your head motion occurs to the time that it travels down the cord, gets computed, passed back to the head-mounted display, and then the game screen is fully rendered as a result from that head motion. Now, thankfully, most critical settings for VR hardware has managed quite well to resolve this problem, and using the default settings for most head-mounted display manufacturers will handle all of your latency issues. Now, in the case of whichever application or hardware you might be using, whether it's Oculus, PlayStation VR, or HTC Vive, we recommend that you avoid any changes to rendering schemes and optimization unless such changes are core to your product. Rendering is another aspect of the let's go back. There we go. Rendering is the next opportunity that you have to make some kind of meaningful change in your experience. The HMD lens applies a pincushion distortion, which makes the oh, sorry about that. Let's head back. There we go. I apologize. I've lost my mouse. That's okay. We'll manage. The HMD lens applies a pincushion distortion, which makes the display screen appear to occupy a wider field of view. Therefore, the software will it often uses a barrel distortion shader, which corrects that distortion, and is by applying the barrel distortion to the image, corrects for the lines that have been bent. So effectively, what that means is you've got a very, very narrow field of view on your display, but the lens will make it seem as though you have a much wider field of view. So for this reason, we recommend that unless it's core to your business, avoid the temptation of making your own rendering shaders. Maintain immersion throughout the entire experience. Never affix a UI element to the user's face. You want to make sure that the user has presence at all time and has complete faculty to look around the environment at all times. Post-processing effects and UI elements that you do use in your game, if you're using any kind of some kind of a bloom effect or maybe a haze, it has to be in sync with both eyes. It has to be rendered in stereo and should only differ in order to create depth effects, differing from eye to eye. Differing elements or elements that align poorly are very disorienting, and this can be avoided by rendering UI elements in world space. In other words, don't render them as a post-processing effect, render them actually in world. As it relates to your avatar, the number one rule that I have to share with you is that the avatar is not a camera. The avatar is your guest. Do not fall into the trap of cinematic action genre camera techniques. Avoid zooming in and out, and avoid flying camera effects, as they'll cause disorientation and exacerbate sim sickness. It's all really cool when you've got a guy on a motorcycle that's in the middle of a car chase, and he dips his motorcycle and slides underneath a truck. That's awesome. Please, 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 for goodness sakes, don't do that to your guests. A chase camera is a one-way ticket to Vomit Town. As it relates to head tracking and positional tracking, head-in-hand calibration is highly recommended to ensure positional tracking is as accurate as possible. It can be done on the welcome screen of your experience. Hey, welcome to the experience. Please look at this dot. Please hold your hands out. And then you can take a snapshot of their measurements. Be sure to avoid visual glitches that result from camera interpretation with objects in the game. So if there's any sort of camera interpenetration or collision, the best way to resolve that is not by constraining the camera, which can cause disorientation because there's no correlation between what the camera is doing and what you're actually experiencing, but rather use an opacity change on the object. It is far better to have the object disappear and to risk disbelief than to cause some sort of mismatch between what the player is experiencing and what their body is feeling, because one leads to disbelief, but the other one leads to nausea. Okay? For body position, make sure that your experience has a one-to-one correlation with the user's body. Matching what you see your body doing exactly to what you observe is critical to achieving immersion. As a case study, when we did our Dragonflight in 4D experience at DreamWorks, we created a custom saddle to precisely match the actual saddle that was used in the game. So when the guests were actually seated in the experience, they were at the exact same angle and their hands were in the exact same position as when they were in the game. The ground and horizon are critical components to VR space, and ensuring stability and comfort for the users is critical. Avoid rotating world space or slight camera rotations in any artistic or unnatural fashion. Similarly, walking in one direction while orienting the camera in another direction is problematic. So in video game genres, you often walk one way and then you're strafing but then shooting in another direction. It doesn't really work in VR. It can cause a mismatch between what you're observing and what your body is feeling. It may be an interesting aesthetic choice to tilt the camera or do something, some curious camera work, but it is disastrous when it comes to avoiding disorientation. So the camera should always be stable and consistent with the head orientation. The most comfortable experiences are those that minimize the need to look around while moving. It's also really important to make sure that you have some kind of a horizon that will ground the player. For third-person content, the player will identify in real-world proportions, which can be pretty awesome. This causes a shrinking dollhouse effect on the gameplay content, since players still feel as though they retain their own bodies, regardless of whether or not they're bodied or unbodied. Therefore, they will see the world, if it's particularly small, as though they were a giant. And this can have a really kind of a charming and immersive effect, especially if you're some sort of a dungeon lord moving monsters about in your dungeon, or if you're moving people around in a small town. It's pretty awesome. It can also have the reverse effect if you want to have a game where you're a small and timid mouse trying to fend off natural enemies such as cats and whatnot. Then it can be incredibly immersive to have a different perspective. For third-person content, the player will identify in, right, so therefore, guidelines for acceleration and movement for the camera still apply to third-person perspective, regardless of what the avatar is doing. Users must always have the freedom to look around the environment, and a comfortable forward-looking gameplay setting is recommended. So when I say that the camera rules still apply, even in third person, this is true. If there is a slowly accelerating camera, then it's going to cause nausea. You want quick, sharp camera movements that will instantaneously leap to a constant vector, rather than any kind of a slow acceleration, slow deceleration. Even if you're just following around a little tiny man that's just jumping around your screen. So allow me to emphasize, avoid acceleration. Any acceleration causes a mismatch between the user's perception and the vestibular system. It's a best practice to avoid motion as a core mechanic in any VR experience. If motion is required, try to align the type of motion with real-world speeds. Be sure to opt for linear motion with zero acceleration. So typically, motion curves will be a nice little bell curve if you're speeding up and then slowing down. In VR, you want instant acceleration to nominal speed, instant deceleration. Now, while this might be visually jarring, it is far better to be visually jarring than to have any kind of nausea resulting from acceleration. Remember, acceleration also refers to any change in motion by the user, regardless of whether or not you have a constant speed. That means that if you're traveling in an arc, then you're experiencing an acceleration, even if you're going at a constant speed, right? Centripetal force. Traveling in an arc, even at constant speed, creates an outward acceleration that is experienced in our vestibular system, or at least should be perceived. And since we're sitting on a couch playing VR, we don't feel it, and therefore, vomit. So be sure to avoid any kind of arc motion if you can. It's incredibly challenging. You often have to create some kind of fiction in order to account for this. Now, teleportation is one of the best fictions we have. In many VR experiences, having a success with this medium of motion. But with teleportation, a degree of caution is recommended, since teleportation can also cause disorientation. Make sure that you give the user ample visual feedback so that they can retain their bearings. Teleportation might not be right for your game. It might be effective as a form of locomotion, but you have to have a fiction that accounts for it, okay? All mobility should be controlled by the avatar whenever possible. Avoid camera mechanics that simulate shaking or bobbing, since this causes unwanted accelerations. One of the classic rookie blunders is when you have this sort of like walking head bob while moving forward. Don't do that. With vehicles are a great way to afford comfortable movement in VR experiences, for the reason that there is a cabin surrounding the player. And this often has a grounding effect because it occludes the vast majority of any of the disorienting movement that you see in your peripheral vision. You've got this nice, the smaller the windows, the better. And if you have a vehicle that has large windows, then you want to make sure that you offer other grounding mechanisms, such as a stable horizon line. With a stable horizon and a minimal cabin, you can eliminate the vast majority of sim sickness in your game, as is evidenced in Eve Valkyrie. Best practices with user interfaces. Since VR is a new medium, we must also create a new user interface paradigm. Simply copying old best practices often results in unfortunate consequences. We encourage you to ensure the player has freedom of vision. The player needs to be able to look around constantly around the world at all times, even in menus. And mixing different rendering paradigms, such as flattened video and stereoscopic world space, can be jarring and ruins immersion. Menus should ideally occupy world space and should not be parented to the avatar's head. Please don't slap a menu on top of someone's head. Now, it should be said that even though I'm offering best practices here, you can break rules. It's okay to break some rules, and I encourage you to do so. I have some students that are doing a head-mounted display, but it's being done with the fiction that they're wearing a helmet, and it's very, very minimal. It's almost got like a pinstripe, tiny thin line, and it's outside of the main 30-degree arc of their vision. So it doesn't occlude much of what the player's seeing, and therefore, it works. Optimization is your friend. It's the one lever that we have the single greatest control over. Manufacturers specify that your VR experience should achieve a 90 frame per second minimum. But we recommend that you shoot for 120 frames per second. And by the way, that's 120 frames per second rendering over 2 cameras. Traditional video games generally work at 30 frames per second on one screen. Now you've got to get to 120 frames per second rendering from 2 cameras. That is a 16x multiple. It's crazy. But you can do it. You can do it. Optimization is the key element that you have at your disposal, and the goal in all cases is to hit your solid frame rate, ideally without compromising visual quality. I say ideally because, given a choice, I would always sacrifice visual quality in order to make sure that my guest has a comfortable, optimal experience. For those of you who are unfamiliar with the techniques that I have listed here, I have provided a longer deck, which I do invite you to download from my website, and the address will be listed at the end of the talk. And in the expanded deck, I'll go into detail about all of these optimization basics. So in closing, gameplay and immersion in VR is a function of technical understanding of how the medium works and being dedicated to using the right practices while building the most compelling experiences for our audiences. That's it for my talk. Thank you very much. And at this time, I'd like to open the floor for questions. Any questions out there? Yes? Is there a microphone? Why don't you go ahead and just shout it out, and I'll repeat the question.
Yeah. So there's a lot of discussion on the internet about how to prevent nausea.
Okay, yes, please go ahead and repeat.
I think I have it turned on, but I'm not sure.
Yeah, here we go. So there's a lot of pretty heated discussion about how to prevent nausea and how to navigate in games. And it's almost as if there's kind of a loud minority that want to be able to wander around continuously without teleportation. Some of them even admit that they had to train themselves pretty hard to be able to, say, play Onward, without feeling nauseous. So they have you have this kind of an iron stomach brigade that have trained themselves, and they want nausea-inducing navigation. Do you think that's a good idea? I mean, usually they say, all we want is the option to do it. But what do you think?
That is a good question. So the challenge then is, do we, as designers, give players the option of simply fighting through the nausea and giving them complete freedom of motion? It seems like a compelling proposition. And to be clear, I've been developing in VR for so long, I'm completely broken. But that said, I still prefer to avoid it at all costs. But that's me. I think that at the end of the day, it is doing a disservice to the medium if you create an experience that only 20% of our audience can truly appreciate and enjoy. The other 80% are going to just say, oh, I can't play that game, it makes me sick to my stomach. And I don't think that's good. I don't think that's good for the medium. Far better to avoid any kind of of conflict with the vestibular system at all, provide an experience that leaves our audiences wanting more. And I fully believe that technology will solve all of these problems sometime in the future. After all, we've got, thanks to Moore's Law, we've got miniaturization, we've got new haptic feedback input devices that are being developed even as we speak. At some point, we're going to solve the problem of having some way of simulating those g-forces that cause those mismatches. And just in case in point, at Spaces, we're working on theme park rides that use all sorts of robotics that enable us to create those g-forces and create perfect matches with the kinds of vehicle experiences that we want to make. So these are going to become, these are coming in the future. And when we have those tools at our disposal, then yes, I think that we should make those really kind of exciting vehicle games. Or even, I don't know, I can imagine a future where we have harnesses that can lift our bodies and allow full human motion. It's a good dream, right? So, but until then, I think that we should categorically refrain from making anything that is going to be a disservice to the medium. Yes?
Yeah, so I don't know when I read about it, but a couple of, like half a year ago, they were researching the nose reference point. Have you tested anything of that? To put a VR nose as your reference point?
Absolutely. So about a year ago, researchers put an artificial nose inside of the experience, and regardless of the shape, the color, the size, most users didn't notice that the nose was there. It was just sort of a blur in the middle of their face, and apparently it actually moved the needle as it relates to grounding the player and reducing sim sickness. But it reduces sim sickness. It doesn't cure it. It's not a fix. But it is an excellent technique. I do advise all of you to think about all sorts of techniques like this that will further ground your players. The nose is one. Another thing that we developed at Spaces is the blink. Whenever there is a transition, instead of fade to black, we always prefer to do a blink because it helps to ground the player in their bodies. And the more that you can get the player at exactly the right angle and body shape, the better. For those of you who are Unity developers, there's an amazing product called Final IK that will allow you to finally bridge the distance from the disembodied hand to the body. It will solve from the wrist all the way down the elbow to the body, and it will even do the solving for the hips. So that's another way that you can further immerse your players in their virtual bodies. You first. Final IK. Just Google Final IK on the Asset Store. Yes?
A lot of VR that I've seen has been all about experiences rather than story. And I'm interested in narrative. It's kind of blown my mind, you going on about the incredible restrictions that there are on making sure that people don't throw up. What sort of stories do you think, have you seen any story-based games working rather than experience-based games, and where do you think that might work?
So, narrative in VR. I think that there is incredible potential for narrative in VR, but the best piece of advice I have for storytelling is it can be found in lessons that have already been shared with us by other mediums. For example, if you remember, your guest has complete and total faculty in a world that for all intents and purposes is real. So you should look to theater and immersive theater for your answers. There's an amazing show in New York that's running right now called Sleep No More, in which audiences attend a show of Macbeth in a warehouse. And it's the classic Shakespearean tale of treachery. But in this particular experience, guests are invited to choose which actors they want to follow throughout the entire evening of the performance. And the actors will separate, and they'll head into one chamber to discuss all the plots and machinations and treachery, and others will go into another room to talk about their visions of ghosts. It's amazing. Every single night, you could go back and see the show a dozen times and see it would be completely different every single time. And in this case, the user is a witness. And that is an excellent way of allowing a narrative to unfold. Another way is branching narratives using choose-your-own-adventure mechanics. This is, if there is a challenge, if the challenge is solved or not solved, then there's going to be consequences, regardless of whether or not you're successful. And the outcome of that consequence can be a branch in your narrative. So when you're talking about narrative in VR, look to role-playing games, look to theater, and remember that for all intents and purposes, it's like a live-action role-playing game. Yes, next question.
I have a hard time phrasing this, but in terms of like how technology is evolving, and we have voice activation services, or say we have Google Go, you have Siri, and you have all these great examples of how voice recognition is moving forward as a technology as well. How do you see that affecting virtual reality somewhere down the line?
That's a great question. So one of the challenges with virtual reality is that we are very, very limited by the available input devices that we have. Because one of the things we always encourage developers to do is to ground their user interface in reality. You know, if you're trying to get from one place to, if you're trying to get upstairs in a building, you have this amazing thing called an elevator, and the user interface is right there. You just push the button. You've got these telephone devices, and you've got all sorts of implements in the real world that you can reproduce in your video game. Voice is another fantastic input device because when you're in VR, you don't have a keyboard at your disposal. So I think that voice recognition is going to be huge. Now, I've had some students that have experimented with voice recognition as an input for a Gear VR experience, and it was very, very effective. They were able to do some really, really complex things just through voice activation. And as voice recognition technology gets better and better, then we'll have, I think that it will become incredibly viable as a means of input. I think that the other thing that we can count on is that haptic gloves with finger motion sensory will also help us in that regard. But do look up some of the modules that are available for Android devices. There's some that already integrate with Unity. Any other questions? Okay, I've got to the end of my time, so thank you all very, very kindly. Get out there and make some great games.